Hi, and welcome to the video on the Half-Life Candium lab. By this point, you should have collected your data. A couple of things I want you to note for the data. In the time column, it should be the total elapsed time. So on your bag, it would say to shake it for either 8 or 10 seconds. What you're going to list here are is the time that has elapsed from the beginning. So let's say, for example, my bag said 12 seconds. You have to shake it for 12 seconds. The first time I shook it for 12 seconds, and I get some data. And then the second time I shook it for 12 more, that would mean a total of 24 seconds, because 12 plus 12 is 24 seconds have passed. And I'm going to put 24 here. So these times should be multiples of however long you were supposed to shake it. Also, in the number of undecayed candiums, the first box here is where you put your initial amount. So underneath where it says initial amount, how much candy was there initially. And then you're going to put the number of candiums that had the M side up, so they were still radioactive undecayed for each trial. Here is the total number of greeniums. So when you first start off, you have no greeniums, but then when some of the candiums decay, you replace them with greeniums. So in this first trial, I replaced the 22 candiums with 22 greeniums, and I put 22 greeniums or split peas into the cup. In the second trial, 11 more decayed, so I needed to add 11 more greeniums to it. And so you'll notice here that my number is not 11, but it's the 11 plus 22, the total would be 33. So how many greeniums in total? So these numbers, the greeniums should go up, the candium should go down over time. All right, now we need to calculate the percent. To calculate the percent, what you're going to do is use these two equations or formulas at the bottom. For the percent candium, it's the number of undecayed candium divided by the initial amount times 100. So the number of undecayed candium would be here, and your initial amount is 50. So I'm going to show you the math I do here. I'm going to take the undecayed, which is 28, divided by the initial amount, which is 50. And I'm going to multiply that all by 100. And when I do that in my calculator, 28 divided by 50, I get a decimal, and then I multiply that by 100, and that gives me 56%. All right, I'm going to do the same thing here. This time I would take the 17, which is the undecayed, divided by my initial amount, which is 50, times 100. And I put that in my calculator, and I get 17 divided by 50, which is a decimal. Then I multiply it by 100 to make it a percent, 34%. Okay, and so on. Now, remember, you're going to use your numbers. So I have 50. If you have 52, that's the number that would go in the bottom. All right, if you had 39, that's the number that goes in the bottom. So use your numbers. You're going to continue that on so you get all the percentages here. And so these values would be the percentages, and fill that in. Then we're going to go over to the greeniums. The greeniums are, we're going to do this formula. It's the number of greeniums in the cup divided by the initial amount times 100. So here I have 22 greeniums. My initial amount of candiums is still 50. Okay, so that didn't change. So I'm going to divide it again. In my case, it's by 50, and then times 100. When I divide 22 by 50, times, I get a decimal, times by 100 to make it a percent, and it's 44. Okay, so then that's the value. Let's do one more example. This time I'll take the 33 divided by the initial amount, of which is 50, times 100, and then I get a decimal, so I'll multiply by 100, and I get 66. Okay, all right. So you're just going to keep on going until you get all of this data filled out. Once you get the data filled out, the next thing you're going to do is start doing your data analysis. So in your data analysis, it asks what happens to the amount or percent of candium over time, and explain why it happens. And the second one is what happens to the amount or percent of greenium over time, and explain why it happens. So with that, what we're going to do is we're going to look at our data, and you can look at either the percent or the amount. Let's just look at the amount here because I have that all set up. So what happens to the amount of candium over time? As we go down, what happens to the amount of candium? Does it increase or decrease? And you have to think about why that is. So remember, one of the things that Candium is doing, it's representing a radioactive isotope, and radioactive isotopes decay over time. So is that what we're seeing here with these numbers? Okay. Then the second one is asking what happens to the grenium over time. So if you look at the number of grenium over time, what's happening over time? Is it increasing or decreasing? And why is that happening? Okay, so remember the greniums were being formed from the decayed candium. So does that make sense? All right, once that's done, now the next one says, notice when you add the percent of candium and percent of grenium for each trial. Is the sum is always 100, and why? So let me go ahead and put in the rest of my percentages here. You, of course, are going to have different values. So when I do all the math here, I get 16%. This is 6%. 6%, and then finally 0%. And over here, I get 84% and 94%, 94%, and then 100. So if I add 56% and 44% together, that gives me 100. 34 plus 66 gives me 100. 16 plus 84 gives me 100%. So every time I add them together, I always get 100, and the question is why? So why do you think that is? Why would the number always be 100%? I want you to remember what's happening during the lab. Every time you remove a candium, does it just disappear, or do you replace it with a grenium? So thinking about that, why would this percentage remain constant? If you prefer, you can think about the numbers instead, the amounts. Every time you add up the amounts of candiums and greniums, they always will equal whatever your initial amount is. So it's the same kind of question. Why is that number always consistent? And thinking about what happens to the candiums when they decay. Do they disappear, or do they get replaced by a grenium? Those are the first 3 data analysis questions. The next one is to plot, and for this you're going to follow the instructions in Schoology about how to plot this using Google Sheets. Once you've plotted it, you're going to sketch your plot, and this is just a rough sketch. So I have my y-axis, my x-axis, they're labeled properly, and I put in some my best fit line, which is that line, that curved line that goes through the dots, and I put in my dots. Now for the rest of the questions, I'm going to use the best fit line in Google Sheets. So not on the paper, but in Google Sheets, because the paper is just an estimate. And you're going to use your Google Sheets to answer questions 5, 6, and 7. So let's start with question 5. It says, let's take a deeper look at our graph, candium versus time, and using your best fit line, so that will be the curved line that you created through the dots, fill in the table below. So notice in our table we have the percent candium. So they're giving us what's on the y-axis, and we want to find the time. So what we're going to do is in Google Sheets, so not on the paper, but in Google Sheets, you're going to find 50. For our first one, we're looking for 50%, and you're going to go over to the best fit line, and wherever we're at the 50. Now we want time. Time is on the x-axis, so then we would go down to the x-axis, and we would figure out what time that would be. Now if I do that in Google Sheets, the value that I get here is 14 seconds. Remember, this is time in seconds, by the way, so 14 seconds. I would do the same thing for 25. I'll go over at the 25%. We're just analyzing our data. And then I go down, and in Google Sheets, that's 28. So again, you're going to use your Google Sheets. Don't use this because it'll be a little confusing. When I do it for 12.5, I get a value of 42. So you're using the table in Google Graph and Google Sheets to get this data. Now it says compare the time it takes for candium to decay from 100 to 50, from 50 to 25, and from 25 to 12.5. So what you're going to do is you're going to look at from 150, how much time did that take? And for me, it took 14 seconds. Okay, so we're comparing. So in order to compare them, I need to know how long it took to go from 100 to 50. Now I want to know how long it took to go from 50 to 25%. All right, so once again, from 50 to 25, how long does that take? From 14 to 28 seconds. All right, And then you're going to do the same thing here from 28 to 42. And then you're going to use that information to answer a question. Do you notice a pattern? Okay, are the numbers similar? Are they very different? What do you notice with the numbers? Once you've done that, the last question says, if your sample has 75% candium, how long was it decaying? So in this case, they're giving me data from my table, from my graph. The data that they're giving me is 75%. So that means I know what's on the y-axis. And I'm looking for how long. How long is the time? So that you're going to get from the x-axis, just like you did before. 75, and then you would go down and then figure out how long it takes. And again, you would use Google Sheets. Use your Google Sheets and the best fit line. Now, this is a quick note here. This is similar to what you did. Remember in the radiometric dating activity where you had the different layers and you took a Geiger counter to determine the age of the objects? And the way that you determined the age was that you used the graph that was provided to move the cursor, the double green arrow, to match it, the percent, and then you took the percent that matched what was on the Geiger counter to the time. That's what we're doing here. We're matching our time, our percent, sorry, to a time. All right, so we're doing the same thing. So there's a quick note here. All right, that's the data analysis part. The last part is the PostLab questions. So with the PostLab questions, we're really starting to get into this concept of half-life, and you did do a play posit that talked a little bit about half-life. But a lot of this you can also get from your understanding of the lab. So this first one is showing 3 different samples that contain a mixture of candium and greeniums. Based on your experiment, which sample has been decaying for the longest? And which one has been decaying for the least amount of time? So let's go back to this question about what happens to the candium and the greenium over time. When you first start off, notice you have 100% candium and 0% greenium. But then over time, what happens to the candium? Does it increase or decrease, okay? And what happens to the greenium? Does it increase or decrease? So based on that information, when you look at the relative percents, you can tell, like this has 25% candium and 75% greenium. That means we have more greenium here. Would that be something that you see at the beginning of the experiment or towards the end? Here we have 90% candium and 10% greenium. Would you see that at the beginning or at the end? And finally, this last one, there's a correction here. That should be 50%. We have 50-50 of each, okay? So where would you see that? So you're looking for which one is the youngest sample, that means at the beginning of the experiment, and which one is the oldest, meaning at the end. All right, finally, here you have a reading, and you're going to use your data. It says it's time it takes for half of the radioactive isotope to decay. You're using analysis question number 5. So remember in analysis question number 5, how long did it take for half of it to decay? One place you can start is at 100%. What's half of 100? That would be 50%, right? So how long does it take to go from 100 to 50%? The time that it takes to do that, that's your half-life, because the half-life is the time it takes for half to decay. Using your analysis question from question 5 and 6, was your half-life constant? So in question 3, they're asking, what does constant mean? Does constant mean it changes all the time, or does it stay the same? Once you've answered that, was your half-life constant? So remember here, you were comparing the time it took to go from 100 to 50, 50 to 25, and 25 to 12.5%. You notice that for all of these, you're dividing by 2. It's decaying. Half of it is decaying, right? So each of these would represent one half-life passing. So that the time going from 100 to 50, 50 to 25, 25 to 12.5, were those times consistent? So you would use that to answer this question here. Finally, you have some more data analysis. So you would do these data analysis using this table here. Do your best to answer the questions based on your knowledge of half-lives. All right, I hope you found this video helpful. Have a quality day.